This is assessment task 2. I first start off by clicking the reset button on the Arduino to go from the start, and we can tell it's working by the light flashing green. We put in the password of 1234 and it begins the process. I turn the potentiometer to show that it is working and the brightness is changing, and it is changing on the serial monitor. Then I proceed to click the first button, which starts the series. We can see it flashes the LED and then turns to yellow. We can see the yellow flashing as well, and then it turns to red. The potentiometer is still working as we can see the brightness change here. Next, I click the second button to begin the second half of the sequence. We can see it flashing, meaning it's working, and it's back to the start. Now we are testing if it works asynchronously. So I do the same. I reset it by pushing the button and I put in the password. Then I start the sequence by clicking the right button, and it's working. Then I proceed to click the left button, and it proceeds to stop. We'll just quickly go back to the recording of the serial monitor in the first example. As you can tell, the status on the serial monitor after we put in the password, thus then, it is updated every second. This is a snippet of our sequence. We did basic mathematical calculations by adding 1 per digit to see in our sequence how many times each color flashes and at what hertz, as per assessment task 1. But we did include the calculations in which assessment task 2 assigned us to, which was making D 5 seconds and making F 4 seconds respectively. One of the main aha moments within our project was realizing that going from Tinkercad to an actual physical Arduino and hard breadboard was quite different, and we had to do specific calculations to counteract that difference. The main differences between working individually in A1 and as a team in A2 was it was much easier to assign each person a specific task to do, thus the workload was spread out quite evenly. Some of the improvements we made from AT1 to AT2 was specifically on the breadboard. The specific wiring structure we made different, so it was much easier to understand. The wiring of the resistors were put off to the side, so it was easier to see which resistor connected to which component in the breadboard, as well as the LED resistors were set up in a specific way, so it was much easier for us to read when comparing from Tinkercad to an actual physical breadboard.